Milk Minute!
Good day, grade 8 learners! At the end of this episode, you are expected to illustrate theorems on triangle inequalities. And now, let's proceed to the importance or application of triangle inequality in real-life situation. Triangles are not just important in mathematics, but are also fundamental to the way we build our environment. We often observe them in our everyday lives. And triangle inequality theorems are also useful in engineers because they can find a reasonable range of values for any unknown distance. So this can be extremely useful when trying to find a rough estimate of the amount of materials needed to build a structure. And it makes estimates more accurate and engineers can plan better. And in addition to this, triangle inequality theorem is a useful tool for checking whether a given set of three dimensions will form or create a triangle.
You are listening to SDO Isabela radio-based instruction.
Learning never stops in Math Eskwela, your school on air.
Your partner in achieving fun learning experiences. Let's listen, enjoy, and have fun in learning mathematics. Stay tuned.
Good day, dearest grade 8 learners. I am glad to be with you again and guide you today as we about to start our fourth quarter episode in Mathematics 8. I hope that you will learn more things about our topic. This is DepEd Radyo Eskwela, your school on air in Mathematics 8. I am your radio teacher, Sir Alexander Respicio. How are you, dearest learners? Are you excited to learn new things today in mathematics? Yes! I am hoping that you are all good today and eager to learn. Let's find the most comfortable place for you to study and get ready because we are about to start our lesson for today. Triangles are everywhere around us. It is also the strongest shape, capable of holding its shape and having a strong base. By using the triangle inequality theorem, an engineer can find a reasonable range of values for any unknown distance. This can be extremely beneficial when trying to find a rough estimate of the amount of materials needed to build a structure with undetermined lengths. So let's start now our lesson about Triangle Inequality Theorem. The Triangle Inequality Theorem states that the sum of all lengths of any two sides of a triangle is greater than the length of the third side. It means that if the sum of the two sides is less than or equal to the measure of the third side, then the sides cannot form triangle. Take note, if A, B, and C are the sides of a triangle, then A plus B is greater than C. Let's have some examples about triangle inequality theorem. For instance, we have a triangle and labeled as A, B, and C respectively. Therefore, AB plus BC is greater than AC. It can be BC plus AC is greater than AB, or AC plus AB is greater than BC. Another one. Use the triangle inequality theorem to tell whether a triangle with lengths of 5, 8, and 10 respectively can have sides with the given lengths. So let's try. First, let's have 5 plus 8 is greater than 10. Since 5 plus 8 is equal to 13, then we have 13 is greater than 10. Then the inequality is true or correct. Next, let's try another one. 5 plus 10 is greater than 8. Since 5 plus 10 is equal to 15, then 15 is greater than 8. The inequality is true again. Last one. We have 8 plus 10 is greater than 5. Then we have 18 is greater than 5. It's true again. Therefore, the sum of each pair of side lengths is greater than the third length. So, a triangle can have a side lengths of 5, 8, and 10. Let's have another example. Let's try or check 7 and 9 and 20. First, we have 7 plus 9 is greater than 20. Is the inequality correct? Very good. The inequality is not correct. It is false because 7 plus 9 is equal to 16, and 16 is not greater than 20. Next one. 7 plus 20 is greater than 9. Is the inequality correct? Yes, it is correct because 27 is greater than 9. Last one. 9 plus 20 is greater than 7. Is the inequality correct? Very good. Since 29 is greater than 7, then the inequality is correct. But then, not all three inequalities are true. So a triangle cannot have 3 side lengths. For the next example, we are going to find the range of values for x using the Triangle Inequality Theorem. The measure of a triangular shaped garden are 5 feet and 8 feet. What is the possible measure of the third side? So we have 5, 8, and x as the length of the sides of the triangular garden. And later, we are going to find the value or measure of the third side. First, let's evaluate the following inequalities. Let's try 5 plus 8 is greater than x. Then we have 13 is greater than x. Next one, 8 plus x is greater than 5. Then we got x is greater than negative 3. And the last one, 5 plus x is greater than 8. So we have x is greater than 3. Since we got x is greater than negative 3, x is greater than 3, and 13 is greater than x, then we have the range is x is greater than 3 but less than 13. The range now will help us to find the value measure of the third side. What do you think are the possible measures of x? Very good. The possible measures of the third side are from 4 feet to 12 feet. We are now done at the Triangle Inequality Theorem. Then we proceed to Exterior Angle Inequality Theorem. Again, it is Exterior Angle Inequality Theorem. Let us first define exterior angle and remote interior angles. An exterior angle for a triangle is an angle that forms a linear pair with one of the angles of the triangle. Remote interior angles of a triangle are the angles that do not form a linear pair with the exterior angle. Take note also that the sum of two remote angles is equal to the measure of its exterior angle. The exterior angle inequality theorem states that the measure of any exterior angle of a triangle is greater than the measure of either of its two remote interior angles. There are also 6 exterior angles formed when all of the triangles are extended. Let's have some examples of exterior angle inequality theorem. Find the measure of the exterior angle DBC given measures of angle A as 49 degrees and the measure of angle D is 68 degrees. As what we have said a while back, that the sum of two remote angles is equal to the measure of its exterior angle. So we can say that angle A plus angle D is equal to angle D, B, and C. Then what is the measure of angle DBC? Exactly. DBC is equal to 117 degrees. Let's have the next example. Angle UST is the exterior angle in the triangle URS. Angle U and angle R are the remote interior angles. If the measure of angle UST is 120 degrees and the measure of angle R is 50 degrees, find the measure of angle U. Then we have the equation angle U plus angle R is equal to angle UST. Substitute the value of angle R by 50 and angle UST by 120. We got angle U plus 50 is equal to 120. Then what is the value of angle U? Very good. Angle U is equal to 70 degrees. To get 70 degrees, transpose 50 degrees to the other side of the equation. Therefore, 120 minus 50 is equal to 70. Take note also that the sum of all the measures of the interior angles of a triangle is equal to 180 degrees. Another one. The sum of each interior angle and its adjacent exterior angle are supplementary, meaning it is also equal to 180 degrees. Let us now proceed to our last topic, which is Hin's Theorem. The Hin's Theorem states that if two sides of a triangle are congruent to two sides of another triangle, and that included angle of the first is larger than the included angle of the second, then the third side of the first triangle is longer than the third side of the second triangle. I'll repeat. The Hin's Theorem states that if two sides of a triangle are congruent to two sides of another triangle, and that included angle of the first is larger than the included angle of the second, then the third side of the first triangle is longer than the third side of the second triangle. For instance, we have triangle ABC as the first triangle and triangle DEF as the second triangle, and for instance, side BC is congruent to side EF and AB is congruent to side DE, then the included angle B is greater than the included angle E. Let's have again some examples about Hin's Theorem. Given two triangles, the first one is triangle AEC and the second one is triangle BFD. The included angle A measures 56 degrees while the included angle F measures 69 degrees. Complete the statement with less than, greater than, or equal. Then from the given, is AC less than, greater than, or equal to BD? Exactly. AC is lesser than BD. Let's have our last example for today's topic. Given two triangles, the first triangle is triangle AML and the second triangle is RML, and AM is congruent to RM and ML is congruent to ML. Side AL is equal to 5 and side RL is equal to 8. Complete the statement with a less than, greater than, or equal. Is angle AML is less than, greater than, or equal to angle RML? Very good. Angle AML is less than angle RML. That's all for today's episode, dearest grade 8 learners. Then now, let's have a quick flashback of what you have learned today. In Triangle Inequality Theorem, the sum of the lengths of any two sides of a triangle is greater than the length of the third side. An exterior angle of a triangle is an angle that forms a linear pair with one of the angles of the triangle. The sum of the remote angles is equal to its exterior angle. And our last topic is Hind's theorem. It states that in a triangle where the included angle is larger, the side opposite this angle will be larger. It is also called the alligator theorem, because you can think of the sides as the jaw of an alligator. The wider it opens its mouth, the bigger the prey it can feed. Now that we're done with our discussion, let's check your knowledge on our topic. On a half sheet of paper, write your name, grade and section, and answer the following questions. Choose the letter representing your answer. Are you ready? If yes, then let's begin. For number 1, the measure of an exterior angle of a triangle is always blank. For letter A, greater than its adjacent interior angle. Letter B, less than its adjacent interior angle. Letter C, greater than either remote interior angle. And letter D, less than either remote interior angle. I'll repeat. The measure of an exterior angle of a triangle is always blank. For letter A, greater than its adjacent interior angle. Letter B, less than its adjacent interior angle. Letter C, greater than either remote interior angle. And letter D, less than either remote interior angle. Next, number 2. The exterior angle YWC measures 132 degrees and the remote angle V measures 30 degrees and the remote angle Y measures X degrees. Find the value of X. For letter A, 102 degrees. For letter B, 111 degrees. Letter C, 120 degrees. Or letter D, 122 degrees. I repeat, the exterior angle YWC measures 132 degrees and the remote angle V measures 30 degrees and the remote angle Y measures X degrees. Find the value of X. For letter A, 102 degrees. For letter B, 111 degrees. Letter C, 120 degrees, or letter D, 122 degrees. Number 3. A triangular garden has two sides measuring 15 feet and 25 feet. What are the possible measures of the third side of the triangle? Letter A, 0 feet to 10 feet. Letter B, 11 feet to 39 feet. Letter C, 11 feet to 40 feet. Or letter D, 11 feet to 40 feet. I'll repeat. Number 3. A triangular garden has two sides measuring 15 feet and 25 feet. What are the possible measures of the third side of the triangle? Letter A, 0 feet to 10 feet. Letter B, 11 feet to 39 feet. Letter C, 11 feet to 40 feet. Or letter D, 11 feet to 40 feet. Next, number 4. It states that the sum of the lengths of any two sides is greater than the length of the third side. For letter A, exterior angle inequality theorem. Letter B, Hind's theorem. Letter C, triangular inequality theorem. Or letter D, all of the above. I repeat, it states that the sum of the lengths of any two sides is greater than the length of the third side. For letter A, exterior angle inequality theorem. Letter B, Hind's theorem. Letter C, triangular inequality theorem. Or letter D, all of the above. Last but not least, number 5. Given two triangles, the first triangle is labeled as triangle ABC and the other one is labeled as triangle XYZ. Side AB is congruent to side XY and side AC is congruent to side XZ. The included angle A measures 52 degrees while the included angle X measures 59 degrees. Using Hind's theorem, YZ blank BC. For letter A, YZ is greater than BC. Letter B, YZ is less than BC. Letter C, YZ is equal to BC. And letter D, none of the above. I repeat, given two triangles, the first triangle is labeled as triangle ABC and the other one is labeled as triangle XYZ. Side AB is congruent to side XY and side AC is congruent to side XZ. The included angle A measures 52 degrees while the included angle X measures 59 degrees. Using Hind's theorem, YZ blank BC. For letter A, YZ is greater than BC. Letter B, YZ is less than BC. Letter C, YZ is equal to BC. And letter D, none of the above. Are you all done? Let's now check your answers. Are you ready? Let's start. For number 1, the correct answer is letter C. The measure of an exterior angle of a triangle is always greater than either remote interior angle. For number 2, the correct answer is letter A, 102 degrees. Next, number 3, the correct answer is letter B, 11 feet to 39 feet because we will get a range of 10 less than X less than 40. And for number 4, the answer is C because triangle inequality theorem states that the sum of all lengths of any two sides is greater than the length of the third side. Last but not the least, number 5, the correct answer is letter A because YZ is greater than BC. How was the quiz? Did you get it all correctly? Good job, dearest learners! For better mastery of today's lesson, perform the remaining activities in your learning activity sheets given to you. I hope that you have learned something today about solving triangle inequalities. If you have queries, you may message your advisor or subject teacher through their messenger or contact number. Just a reminder, submit your modules or last on the scheduled time at the dropbacks intended in your barangays, and always observe health protocols. Again, thank you, dear grade 8 learners, for your cooperation and for listening. I am your teacher on air, Teacher Alexander B. Respicio, signing off. Have a great day ahead. Stay safe and God bless you all. Today's episode was written by Ma'am Ana May M. Sardena under SDO Isabela RPI production.
Patuloy ang edukasyon para sa ating henerasyon.
Sa daan ng pagkatuto ay walang may iwan.
Kaya halina sa Radyo Eskwela!